We will be moving to the next module, that is module 4, CAMs. Your syllabus consists of these topics, that is first classification of CAMs, types of followers, CAM nomenclature, follower motion and motion analysis of SHM, motion with uniform acceleration and deceleration, uniform velocity, cycloidal motion, and drawing the CAM profile with the different followers like knife edge follower, roller follower, and flat faced follower. So to the introduction of CAMs. What are CAMs? A CAM is a rotating machine element which gives reciprocating or oscillatory motion to another element, which is known as follower. The CAM rotates usually at constant speed and drives the follower, whose motion depends upon the shape of the CAM. Almost always the CAM is the driver and follower is the driven. CAMs come under the higher pair of mechanisms. As we already know that in a higher pair the contact between two elements is either point or line contact instead of area, which is in the case of lower pairs. In CAM mechanism, the three essential members are the CAM, which has a curved surface. You can see here the red color, or it may be straight surface. The follower, you can see the blue one which is moving, and the frame which supports the guides. So these are the three things which is very important in a CAM system. CAMs are widely used in automatic machines, internal combustion engines, for the wall movements and all, machine tools, printing control mechanism, and many other cases. Along with CAM and follower, one frame also will be there which support the CAM and guides the follower. Okay, there will be one holding the CAM, other one will be holding the follower. Classification of follower. Followers can be classified according to three main categories. First one is according to the surface of contact. So in this there are four types. First one is the knife edge follower, next the roller follower, flat faced follower, spherical follower. So you can see here the four diagrams are given here. First one, the knife edge follower, the first A, when the contacting end of the follower has a sharp knife edge, we call that as a knife edge follower. This CAM follower mechanism is rarely used because of excessive wear at the tip, because it is a sharp contact, wear due to small area of contact. Okay. In this follower, a considerable thrust exists between the follower and the guide. That is in the case of knife edge follower. Second one, the roller follower. You can see the B diagram. When contacting end of the follower is a roller. At the end, you can see the roller. That's why it is called as a roller follower. Wear rate is greatly reduced because of the rolling motion between the contact surfaces. Very less wear takes place in roller follower. There is a side thrust present between follower and the guide. Roller followers are commonly used where more space is available, like in the stationary gas or oil engines, aircraft engines. In these cases, roller followers are used. Third one, the flat-faced follower. When the contacting end of the follower is perfectly flat, you can see the C diagram, which has a very flat surface. Perfectly flat surface, we call that as flat-faced follower. The thrust at the bearing exerted is less as compared to other followers. Here, in case of flat-faced follower, the only side thrust is due to the friction between the contact surface of the follower and the cam. The thrust can be further reduced by properly offsetting the follower from the axis of rotation of cam, so that when cam rotates, the follower also rotates about its axis. So this is a commonly used type of method to avoid the thrust. So this is mainly used in the case of automobiles, we can see this type of follower. Last one, the spherical follower. It is almost similar to the flat-faced follower. So there is a small variation. You can see the D sketch here. The contacting end of the follower is spherical shape. That's why it is called spherical faced follower. The flat faced follower, high surface stress are produced in flat faced follower, and that's why to minimize that the spherical shape is given here in the case of spherical follower. So seeing the some animations related to these four followers. The first one the knife edge, second the roller follower. These two are almost same, the flat faced follower and spherical follower. Next one, according to the motion of the follower, we have two types. The first one in that is oscillating follower. When the uniform rotary motion of the cam is converted to the some predetermined value of oscillatory motion, some angle, in the sense some angle is already fixed. If the oscillation takes place to that particular angle, we call that as oscillating or rotating follower. Another name given for the oscillating follower is rotating follower. So this is how the ear diagram it looks. You can see here as the cam rotates, the follower can oscillate in its position. Second one is the translating follower, or we also called as a reciprocating follower. Translating follower or reciprocating follower, where the follower is guided to move uniformly in the reciprocatory manner. So when the cam rotates, this is just a reciprocatory movement of the follower takes place. So you can see here, this is the oscillatory motion. So you can see the follower just oscillates from the fixed point with respect to the fixed point, whereas the reciprocatory follower, you can see the reciprocatory movement of the follower. It may be any type of the follower, so it depends on the type of motion of the follower. It doesn't depend on type of the shape of the follower. It just depends on the movement of the follower. This is the second classification. Third classification is according to the position of the follower. Position, here the position is with respect to the center of the cam or the cam axis. Okay, based on that we have two types. First one is radial follower, or we also call that as inline follower. When the motion of the follower is along the axis passing to the center of the cam, is known as a radial follower. If the axis of the follower, so this is at the top we can see the follower. Here there is a cam center. If the axis of the cam and axis of the follower is in a straight line, we call that as radial follower. Okay, so four diagrams are given here. Four diagram are for different followers. First one is knife edge, second roller follower, third one is flat faced, and last one spherical. So you can see here the axis of the follower and the axis of the cam both are in the straight line. If this type of cams we see, we call that as radial follower. Second one is offset follower. So here it is opposite of the previous one. So if the axis is away from the center of the cam axis, so you can see here cam axis and the axis of the follower, there is a small gap. It may be towards the right side or it may be towards the left side. It depends on the application. So any side, on the left side or right side, if it is away from the cam axis, we call that as offset follower. So the distance may be 1 centimeter, 1.5 centimeter, 2 centimeter, so it depends on the application. So if the center of the cam axis is away from the center of the away from the axis of the follower, we call that as offset follower. Next one, the motions. So there are basically three types of motion of the follower taking place. One is rise, cam causes follower to rise. Fall, cam causes follower to fall. Dwell, no output motion for the specified period of motion. So these are the three types of motion taking place. So follower either can move away from the center of the cam. So if it is moving away from the center of the cam axis, we call that as rise. The first one, cam causes follower to rise. That means the follower is going upwards, away from the cam. So in the same case, in the if the follower is moving in the opposite direction, that means it is coming towards the center of the cam. I mean, it is coming downwards. It is a fall of the cam. Okay, rise is going away, fall is coming towards the center of the cam. So that we call second type of motion, that is fall. Cam causes follower to fall. Okay, it is coming towards the center. So rise means going upwards, fall means coming downwards. So these are the two motions taking place. So if there is no motion at all, it is neither going upwards nor coming downwards, so that is the third one, that is a dwell. Okay, that means it may be constant at one particular position. It may be the initial point 0, or it may be at the highest point. Suppose the follower will move to the highest position, it is a rising upwards. Okay, so it is at the topmost maximum point or the peak point. There it will be constant for some duration of time, no downward movement. So this constant period of time, we call that as a dwell period. Okay, so no upward or downward movement. So wherever whatever position follower has taken place in the previous case, it will be at that particular position and will not move downwards or will not move upwards. Okay, so that we call it as dwell. No output motion for the specified period of input motion. Okay, no upward move or downward movement. So in simple words, if I can tell that, dwell means constant, no movement taking place at all of the follower. If that is happening, we call that as dwell. So rise, fall, dwell. These are the three main movements taking place in a cam. Next, classification of the cam according to type of follower motion. That means three types what we have seen: the rise, dwell, and fall. Based on that, we have classification. First one, that is dwell, rise, dwell cam. So this is how the graph looks, the displacement diagram. Okay, so first we have dwell, then the rise, again dwell. So if this type of motion we have, this is how the displacement diagram looks. So if the cam is moving, dwell, rise, return, dwell. So the graph looks like this: first the dwell, then rise, then return, again constant, again rise. This is how the graph looks. Next, third is rise, return, rise, cam. So this is how the graph looks. That means the displacement diagram plot. So these are the different combinations. So it can have any combination. There is no rule that it should have only these combinations. So this is just examples. Next, according to type of follower motion, we have wedge or flat cam. So this is one of the linear cam, wedge or flat cam, which is a linear cam. A linear cam is illustrated here. Okay, this type of cam is formed for on a translated block always. A groove is cut into a block. The distance that varies from plane of translation. Okay, attaching a follower that rides in the groove gives the follower motion. So whatever the follower resides here, that will give the motion. So this type of cam, we call that as wedge or flat cam. So this follower moves through this groove. Next one, a radial or disc cam. So, this four diagrams what you see, we can call this as a plate disc cams, which is a simplest and most common type of cam used. And we are the problems, the cam profile what we are going to do, will be of this type. The plate cam is illustrated here, which is which can have a radial or offset type. Any type is possible. So here it can give the follower oscillatory motion or reciprocatory motion. So this is how it looks. Okay, it can be, so all these comes under radial or disc cam. So this is offset, radial, offset, all these comes under radial or disc cam. Next one, cylindrical or drum cam. This type of cam is formed, you can see the diagram here. There will be a groove cut in the cylinder with a varying location along the axis. So along the shaft there will be different grooves cut, and follower will be made to move on this cylinder, and based on that movement takes place. Attaching a follower that rides in the groove gives the follower motion to the follower. Okay, so you can see here how the movement takes place. It is a cylindrical cam, it's not a disc. So these are the main classification. Next one, based on the constraint. Constraint, we already know what is a constraint. Is a condition which holds the follower. So based on that we have two types here. One is spring loaded or preloaded cam. You can see the diagram or the animation here. A spring is connected to keep the follower and cam in contact. Okay, because of the spring force, follower comes back to the original position. So spring pulls the follower back to the original position. Next, second one is positive constraint, that is the cylindrical cam. Okay, so here no force is acting, extra force, but because of the gravitational force or any other force, the follower will be in contact. No spring or anything is not used here. Okay, so no external force is used here to keep the body in contact. Next we will see some of the main terminologies related to cams. You can see this diagram which indicates different parts or different terminologies related to cam and follower system. First one in that is, the main part in a cam system is the base circle. You can see here the base circle. You can see the base circle here. It is the smallest circle, keeping the center at the cam center. So its center and the cam center will be same. The base circle decides the size of the cam. So what is the size of the base circle depends on that. Depending on that, the cam size will be decided. If you have smaller base circle, the cam will be very small, and if it is very big, the cam will be very big size. Next one, the trace point. You can see here the trace point. Trace point depends on the follower. So it is the point on the follower. You can see here the follower, and it is used to generate the pitch curve. Pitch curve, which is indicated here. You see here pitch curve. Its motion describes the movement of the follower. The trace point movement describes the follower of the movement of the follower. The Now here it is shown the roller follower. For knife edge follower, the trace point will be the tip of that knife edge, whereas for roller follower it is the center of this roller, and flat face will be again the tip of the flat face point or the point of contact. So that trace point will depend on the follower. So for knife edge follower, flat faced follower and spherical follower, it will be the point of contact, the trace point, whereas for roller follower the trace point will be the center of the roller. So there is no rule that always the point of contact should be the trace point. Next one, the pitch curve. As I already said, pitch curve, it is the curve drawn by the trace point. So the point, if you go on joining the trace point, you will get a circle, or you will get a curve, not a circle, you will get a curve that is called as pitch curve. So if we hold the cam fixed and rotate the follower in the direction opposite to that of the cam, then curve generates a locus of the trace point, which is known as pitch curve. For a knife edge follower, pitch curve and the cam profile are always almost the same. Not almost, it's same. Okay. Whereas for the roller follower, it will be more. It will be related to the radius of the roller. Next one, the pressure angle. You can see here pressure angle, which is indicated with the angle phi. It is a measure of the steepness of the cam profile. Okay, the angle between the direction of the follower movement, at what direction it is moving, and the normal to the pitch curve at any point of this cam profile. If you take any point and if you draw a curve, pitch curve, it is called as pressure angle. Pressure angle varies from maximum to minimum during the complete rotation. Okay, so it will be minimum to maximum. So this is a complete rotation. You can see here cam rotation is indicated here. So 360-degree rotation takes place for a cam. So while this motion taking place, pressure angle takes maximum to minimum. Higher the pressure angle, higher is the side thrust and higher the chances of jamming the translating follower in a guide ways. So pressure angle should be small, and this will this should be within the limit of design. So while we design, we have to take care of this pressure angle. And one more thing we have to keep in mind is pressure angle should be less than 45 degree for low speed cam mechanism, whereas 30 degree should not exceed 30 degree in cams for a translating follower. So oscillating follower it is 45 degree, whereas for a translating follower it is 30 degree. So the pressure angle can be reduced by increasing the cam size. If you increase the cam size, pressure angle reduces, or by adjusting the offset. Here the diagram shown is for radial follower. So with the offset also you can control the pressure angle. Next one is pitch point. It is shown here. Pitch point. So the point corresponds to the point of maximum pressure angle is called as pitch point. So where you will have a maximum pressure angle, there it is called as pitch point, and the circle drawn at the center of this cam center passes through the pitch point, which is called as pitch circle. You can see here pitch circle, the dotted one, that is the pitch circle, which is done with the help of pitch point. Next one, the prime circle. Prime circle is here, the dotted one. Prime circle, the prime circle is the smallest circle that can be drawn so as to be the tangential to the pitch curve. The pitch curve is here, tangential to the pitch curve, which will have the center which is same as the cam center. So for the roller follower, radius of the prime circle will be equal to the radius of the base circle. So its radius will be same, whereas for the roller follower, prime circle will be the prime circle will depend on the roller radius of the roller follower. So for knife edge follower, flat faced follower, spherical follower, prime circle and base circle both are same, whereas for roller follower, base circle plus the radius of the roller, the value what you get will be the radius of prime circle. So these are the main terminologies related to cams. Coming to the another main thing while drawing the cam profile is displacement diagrams. So whenever you draw a cam profile, there will be two parts. First, the displacement diagram, and second is cam profile. Displacement diagram indicates the movement of the follower. Okay, displacement can be plotted against the angular displacement theta of cam, and it is called as displacement diagram. In a cam follower, the motion of the follower is very important. Okay, whenever a follower is moving, we should know what path it is tracing, and its displacement can be plotted against the angular displacement. Angular displacement here is the cam movement. What is the angle cam is rotating? If cam is moving 90-degree rotation, what is the path traced by the follower? If you plot a graph, that is called as displacement diagram. Okay, the displacement of the follower is plotted along the x-axis, and the angle is plotted along the displacement is plotted along the y-axis, and angle is plotted along the x-axis. 0 to 360 degree is plotted along the x-axis, and whatever the height movement of the follower is plotted along the y-axis. The displacement, velocity, acceleration are plotted for one complete rotation. So whatever the diagram we draw it for complete 360-degree rotation, not for only 90-degree or only 180-degree, not like that. If you draw a displacement diagram, it will be for entire 360-degree rotation of the cam. That means one cycle, one full cycle of the cam, one full rotation of the cam. So basic requirement for any cam profile. So if you want to draw cam profile, displacement diagram is must. Whatever may be the shape of the follower, it may be knife edge, it may be roller, it may be uh, flat faced follower, or it may be spherical follower, but displacement diagram remains the same. Yeah? So it depends on how the movement takes place with respect to the angle. So that is very important to draw a cam profile. So that is the displacement diagram. So when you draw a displacement diagram, we have to see what are the type of motion a follower takes place. So mainly there are 5 types of follower motion. First one is the uniform velocity, second is modified uniform velocity, third is uniform acceleration and deceleration, that is we call it as UARM. Fourth one is simple harmonic motion, also we call it as SHM. Last one is cycloidal motion. So the cam can be combination of any of these type of motion. So there is no rule that it should be only SHM or it should be only cycloidal. It can be combination of UARM, SHM, cycloidal, or it may be both SHM, or it may be only UARM, or it may be only cycloidal. Okay, so problems can be asked with a combination of any of these follower motion, and that is uniform velocity. So follower here, when the motion takes place with a uniform velocity, so you can see the diagram here which shows the displacement, velocity and acceleration patterns of follower. So first diagram is displacement, second is velocity, third is acceleration. Since the follower moves with the constant velocity, uniform velocity, during the rise means the curve is going upwards, the displacement varies linearly with respect to theta. You can see here 0 to 90 degree, it is linearly increasing, okay, as the velocity is increasing, whereas there is no acceleration at all, but the velocity is increasing very fast within no time, and acceleration becomes infinite at the beginning and end of the race. You can see here beginning it is infinite, at the end it is infinite. Next one, modified uniform velocity. Second type of motion. In the first type, what we observed is that the displacement diagram of the follower in the uniform velocity, we have observed that the acceleration of the follower becomes infinite. Correct? I have told you there at the beginning and the end. Now, if we want the acceleration, that means in order to prevent this, instead of going to infinite, the displacement diagram can be slightly modified. That means we can do small modification. So in this modified form, the velocity of the follower changes uniformly during the beginning and the end of the each stroke. Accordingly, the displacement of the follower varies parabolically. If you modify, you can see here the curve, the displacement diagram. If you see here, you can see here there is a small curve taking place at the starting and end. Okay, so this is the parabolic shape the curve is taking place because of the small modification what we do in the velocity. So this modification, acceleration becomes constant during these periods. So wherever you do the modification, there the acceleration becomes constant instead of going to infinite. So the displacement, velocity and acceleration diagrams are shown here. Okay, this is how the curve looks. Next one, uniform acceleration or deceleration or retardation motion. Okay, two names are there: uniform acceleration, retardation motion. Okay, so this is combination of, sorry, not combination. If we want only acceleration, uniform acceleration, so here nothing to do with the velocity, we can assume a constant acceleration for first half and constant deceleration in the second half. Deceleration is nothing but retardation coming uh, downwards. The resulting motion curve will be two parabolas. You can see here in this diagram, curve is drawn here. This is the first parabola for first half, second parabola for second half. Okay, so this is how it looks when you draw a UAR. This curve is indication of uniform acceleration for first half, uniform deceleration for second half. Okay, so this is the indication of the displacement. So if you want to draw this, we first draw the displacement diagram, then we divide that into equal number of divisions corresponding to the division. If you are dividing here 6 parts, then here 6 parts. So in the diagram what you see here is we have divided the x-axis into 8 parts, so the middle line will be divided into 8 parts. So how much you divide in the horizontal line, same number of parts you have to divide in the vertical line, and corresponding sides, the first half is joined to the uh, first half of the points are joined to the initial O, and remaining half of the points are joined to the end point. Okay, so this is how you will get a intersection point of vertical line and the horizontal line. So that intersection points are used to draw the curve. Next one, simple harmonic motion or SHM. This is when one commonly used simple commonly used displacement, since its design is very easy. So the curve is drawn by the projection of circle about the cam rotation axis, which is shown in the diagram here. There is a semicircle. So the points, the semicircle is divided into different points and they are projected here, and a vertical line is drawn. The intersection is used to draw the curve. So here we can note that even though the velocity and acceleration is finite, the maximum acceleration is discontinuous at the start and end of the rise period. Okay, so here both are finite, we'll get a parabola. Next one, cycloidal motion. So this is one more type of motion where A circle rolls, if a circle rolls along a straight line without slipping, a point on the circumference traces a curve that is called as cycloid. Okay, so we draw a circle here at the starting point or the end point. We divide that into number of parts. So how many parts you divide in the horizontal line? Same number of parts are divided on this circle. So that is projected to get the curve. So all these type of motion we are going to study in detail when we solve the problems. Okay, so this is the next type of motion, that is cycloidal motion. So after knowing about different type of motion, so these three are the main type of motion: the simple harmonic motion, uniform acceleration retardation, and cycloidal. So if you want to calculate the velocity and acceleration for these type of motion, so these are the formulas. So you need to by heart these formulas. So if you want maximum velocity at the outstroke, what do you mean by outstroke? Outstroke means the follower is moving outwards, we call that as outstroke, and if the follower is moving inwards, we call that as instroke. So in other words, outstroke means the curve is going upwards, the rise, the follower is moving upwards, that is outstroke. If the curve is coming downwards, the return or the fall, we call that as instroke. If a follower is moving with the simple harmonic motion in the outstroke, and if you want to find the maximum velocity, we use this formula. Okay, same way if you want acceleration, maximum acceleration, we use this formula: velocity is here, acceleration is here. So in the same way, if motion taking place with simple harmonic motion with the in stroke, that means it is coming downwards with the SHM, and you want to find the maximum velocity, you make use of this formula. Okay, so 12 formulas are there, so you need to by heart this. So these are the some basic introduction related to cams. So coming videos will be related to problems or numericals related to cams. So how to do the cam profile, all this will be taught in the next video.